Good morning. My name is Sangeeta BL, working as Assistant Professor in Vivekananda College of Engineering and Technology, PUttur. So today we'll be studying about the experiment that is a full wave precision rectifier. So previously we studied about the half wave precision rectifier. So now we'll be studying what is a full wave precision rectifier. So there is a difference that half wave precision rectifier we used to get one cycle in one particular cycle, either a positive cycle or a negative cycle. So in case of a full wave, for every positive as well as a negative cycle, we'll be getting the output. So how it is means, we are going to take two operational amplifiers, that is an inverting amplifier. There are two diodes, same as your previous connection, but there is a direction difference in case of a diode, as well as another inverting amplifier. So the connection, do the connection as it is shown in the diagram of a circuit. So initial condition is we take Vin as 1 volt peak to peak. So for Vin 1 volt peak to peak, you can see there are 1, 2, 3, 4 and 5 resistors. So main intention of this precision rectifier in case of full wave is we have to design the R5 value. So in order to design this, I will take the R5 as total resistance R divided by 2, which is nothing but 1 kilo ohm by 2 will give you 500 ohm. So the standard value for 500 ohm is 470 ohm. So what happens is the operation. So first consider a positive cycle. So in case of a positive cycle, so you can see it is an inverting amplifier. So positive, if you give here, if I take this is a positive signal, so the output across this will be a negative which you are getting. So because it is an inverting amplifier. So as you can see, the diode is also negative bias or negative reverse bias. So the diode will conduct with respect to this negative cycle, whereas this diode, it will conduct to positive cycle. So this will be off. So there is no connection here now. Only this connection will remain. So there is a possibility that you will get an output across this. Now if you take the negative cycle, so negative cycle if you give to this, it will be a positive, whereas the output across this point is the diode will not conduct. So this point it is 0. So directly the input will be given to this op-amp, so which is again a negative cycle. So if you give again a negative cycle here, the output across which you get is a positive. So this is the case in case of your full wave precision rectifier. Even though the cycle which you give is negative, the output across you get is a positive. So output, both the outputs which you get across it is a positive output. So main is first if you give the output, that is for positive cycle, you will get the negative. So this diode will conduct, whereas D1 will not conduct. You get the output across the op-amp number, that is pin number 6. Again if you give a negative cycle, this diode will conduct, that is D1, whereas D2 will not conduct. So the output across this is 0. So again this input can be given to this operational amplifier, whereas this will conduct. So both the outputs you can get across positive as well as the negative cycle. So first condition will check what it is for V in 1 volt peak to peak across the CRO. So you can see, as I have said you, channel 1 should be input because you are going to measure the transfer characteristics. Channel 2 should be output. Input should be given in AC because the rectifier will convert an AC to a pulsating DC. So the output should be in DC. So initially one box into your channel 1 has been kept to 1. So it is 1 volt peak to peak. Frequency is 1 kHz for a precision rectifier experiment. And now measure the output. So you can see here. So for positive cycle, show you the proper output. So for positive cycle also you are getting an output. For a negative cycle there is a positive output. So now if you measure the output across this, make it to ground first. Measure what is the voltage you are getting. So this is around, for positive cycle you are getting around 0.51. So that I will take it as Vmax, that is 0.51 volt. So other one, that is for a negative cycle, it is exactly 0.5. So V minima is 0.5. There is only a 0.01 volt difference. So if I have to measure the transfer characteristics now, put channel 1 to ground, channel 2 to ground, bring it to the middle, that is center. Then turn your time division knob to anti-clockwise. Keep the position to the center. Now put input to AC, output to DC. So this is your transfer characteristics. So same as that for positive cycle. So if I take this diagram of the transfer characteristics, so this is around 0.51, whereas this is around 0.5 volt. So there is only a small difference, which is greater. The line across the positive side will be more, because for positive cycle you are getting 0.51 volt, and for negative cycle you are getting it as 0.5 volt. So positive it should be slightly greater than the negative cycle, which you are getting it as 0.5. So this will be your input, 1 volt peak to peak. One side it is 0.5, other side it is minus 0.5. So this is the working of the normal for V in, that is 1 volt peak to peak. So now we will see what is the input for, or what is the output you are getting for 3 volt peak to peak. So same circuit connection you have to do, but only difference is, instead of R5 you using it as 470, you have to use the R5 as 330. So when you do the design, you will be getting the value of 333. So you are going to use the resistor as 330 volt, that is the standard value which you have. So same as the previous case, there is the same connection which will be involved for positive cycle as well as the negative cycle. So you are getting the output. So first I will explain you what is the design of the circuit. So if you take the first cycle, I will consider is V in is 3 volt peak to peak. Same as the assumption R1, R2, R3, R4, it is 1 kilo ohm. First consider for your negative half cycle. So if I give a negative half cycle to this, so diode is given in the reverse bias direction. So it is negative, so this will conduct. The output across which you get is positive, so this diode will not conduct. So what happens? The whole output across this is 0. So you will be left with only this circuit. So if I want to show this, so you will be left with, so neglect this part of the circuit, only this part of the circuit is remaining. So now I need to find what is the output voltage for this circuit. So if I take the inverting operational amplifier output, so V out is nothing but R4, input resistance feedback is R3, that is minus R4 by R3 into Vn. So already we have assumed R4 by R3 is 1 kilo ohm, this is 1 kilo ohm. V in, so now you have to find what is V out. So V in for negative half cycle, so this is the 1 volt, 1.5, which is going to give you 3 volt peak to peak. So negative half cycle you are taking the V in as minus 1.5 volt, that is V in is equal to minus 1.5 volt. So I will substitute it as minus 1.5 volt. So 1 and 1 will get cancelled. So V out we should get it as 1.5 volt. That means if you are giving a V in of negative minus 1.5, the output which I should get is 1.5 volt. So again now we will see what is the output for positive cycle. So if I take the positive cycle, so what happens during a positive cycle is, again we will go through the diagram. So if I give a positive here, so this diode it will be off, whereas the output across which you get is negative negative, so this diode will conduct. So there is an output across this resistor. Again this is given to another inverting amplifier, so again there is an output across this. So there will be two equations. So how I can write the output is, one with respect to this particular op amp, that is minus R4 by R5 is the input into, so this point I will consider it as VB. So this is the input voltage for this particular op amp. Again plus, this is also conducting now. So I have to write the equation for that. So that is nothing but minus R4 by R3, that is R4 and R3 divided into V in. So R4 by R3 into V in is the other one. So now substitute the values. Minus 1 kilo, R5 we need to calculate, VB also we need to calculate. Minus R4 will give you minus 1 kilo by 1 kilo into V in. Now V in is for positive cycle, so positive cycle is from here to here is 1.5. So I need to substitute here 1.5 volt. So we'll calculate what is VB. So VB is the output voltage of this particular op-amp. So I need to take only these resistors. Now D1 is not conducting, the only left part is this one. So I need to write the operational op-amp same formula with feedback resistance R2, R1, whereas the input voltage is V in. So R2 and R1 we know it is 1 kilo ohm. V in is positive cycle, it will take half of the part, that is 1.7. So VB of calculated it as minus 1.5 volt. Now substitute to this V out equation. So V out will be minus 1 kilo into minus 1.5 divided by R5. This is minus 1 kilo will cancel, will be left with 1.5. Now in order to find this, we need to know what is the output voltage of this particular for this particular input. So if I take this positive supply, the output which we are getting is 3 volt. So I need to substitute it as 3 for positive cycle. So 3 multiply this R5 is equal to, so minus into minus will be plus. So 1.5 kilo multiply this R5, it is minus 1.5 R5. So bring this R5 to this side, it will be 4.5 R5, which is equal to 1.5 kilo. So R5 is equal to, so if we divide by 1.5 divided by 4.5, so we'll get 0.333 into kilo, which is nothing but 0.333 kilo, which is equal to 333.33 ohms. So R5 we have designed a value that is 333 ohms. So this is the design part. So after you design, now we know how should be the output. So if I give an input of 1.5 volt as well as minus 1.5 volt, the output which you get is, for positive cycle it is 3 volt, negative cycle it is 1.5. So again there will be a chances of asking the transfer characteristics. So if you are drawing the transfer characteristics for this, so transfer characteristics will be, so first input we have taken it as 3 volt. So this will be 1.5, this will be minus 1.5. For positive cycle I was getting 3 volt. So it should cover in this area itself. So this should be 3 volt. Negative cycle it was 1.5. So it should be half of this 1. So this will be V out. This will be V in. So this is the transfer characteristics for 3 volt peak to peak. Now the same thing we will see in the CRO, how we are getting the output and measure the output. So now what I have to do is, initially I have to set the input. So input I should keep it as 3 volt peak to peak. So in order to do that I need to increase for 3 divisions. So keep it for 3 divisions, that is 3 volt peak to peak now. Now we will see the output for this. So you can see the output, proper output. So for positive half cycle, there is a 3 volt, whereas for negative half cycle it is 1.5. Exactly 1.5 volt you are getting. So this is the output which can be obtained for 3 volt peak. For positive then it will be more, for negative it is less. That is half of this output. So now we'll see the transfer characteristics. Put it to ground, bring it to the middle. Now turn the time division knob to anti-clockwise. Again set the position to middle. Put input to AC, output to DC. So you can see here from the midpoint, this is exactly 3 volt. This should be exactly 1.5. This is minus 1.5. Whereas we are getting an voltage of plus 1.5. So this is the transfer characteristics of V in, which you are giving it as 3 volt peak to peak. So same case again we have to see it for 6 volt peak to peak. Now we'll change the resistor value. So the resistor value which has been used for 3 volt peak to peak, 6 volt peak to peak is 680. So there will be again a change. The main difference between 3 volt peak to peak and 6 volt peak to peak is, for 6 volt peak to peak, for positive cycle you will get the output as half of that input which you are taking, as well as for negative half cycle you will be getting the output as 3 volt. So that will observe in case of 6 volt peak to peak or whichever volt we are considering. So if I increase the voltage, I will check whether we are getting the output. So it is 6 volt, that means I have to keep it as 2, 3 block, 3, 5, increase it to 3. So we are getting it. So I will tell you the design formation now. So same design we are going to follow as in case of 3 volt peak to peak. So we can see here, so initially now I am taking the voltage as Vin is equal to 6 volt peak to peak. That means we will have an input, that is, this will be 3 volt and this is minus 3 volt. According to this, the output which I have to get is, this should be 3 volt, this should be 1.5. This is the output. So this will be your input, this is the output. So same condition now, the same design equation is going to be applied. So if I take the positive half cycle now, so what I have to do in the positive half cycle is same assumptions, that is R1 is equal to R2 is equal to R3 is equal to R4 is equal to 1 kilo. So for positive half cycle now, P out is equal to same as the previous, minus R4 by R5 into VB plus minus R4 by R3. Same design equation, only there is a change in applying the values. Now we have to calculate VB. VB is nothing but minus R1 by R2 into V in. So there is a slight difference now, 1 kilo ohm by 1 kilo. V in will change. Previous case it was 3 volt peak to peak. So positive will be 1.5, negative will be minus 1.5. Whereas in case of this, positive will be 3 volt, negative will be minus 3 volt. So now I am considering for positive half cycle first. So positive half cycle it is now, we are getting it as 3 volt. So I have to substitute as 3. So VB is nothing but 3 volt. So now substitute this, it will be 1 kilo by R5 into minus 3 will be plus 3. Again plus 1 kilo ohm by 1 kilo ohm will be 1. So this particular will become 1. V in is 3. So it will be again minus 3. So V out I will get for this is particular output voltage is 1.5. So 1.5 into R5 minus 3 kilo, is equal to 3 kilo minus 3 into R5. So cross multiply the R5 to this 1.5. 1.5 I have taken because for 3 volt I should get it as 1.5. So bring this 3 to this side. So it will be 4.5 R5 which is equal to 3 kilo. So R5 if I need to calculate, it is 3 into 10 power 3 divided by 4.5, where I'll get a value of 666.6 0.66 ohm. So this is how you calculate the R5 value. Again, for negative half cycle it is the same as this. So negative half cycle, there is only one condition, that is if I give a negative cycle, so this particular will not conduct, so you will be left with V out is equal to R4 by R3 into V in, so minus 1 kilo by 1 kilo. Negative half cycle, this is the negative half cycle, so I should take it as minus 3, so this is minus 3, so minus into minus will be plus, so V out you will get it as 3 volt, so which is nothing but V out for this particular negative 3 volt, you should get it as 3. So what happens in case of transfer characteristics here is, so this is your V in, this is your V out, input you are taking it as 6 volt, 3 volt peak to peak, this will be minus 3, this will be plus 3. So now for negative half cycle I am getting it as 3 volt, for positive I am getting it as 1.5 volt. For negative half cycle I should get it as 3 volt, for positive half cycle I should get it as 1.5. So we can see the transfer characteristics in the CRO now. So initially what you do, set the input. So input it is, I have set it now to 2 into 3 will give you 6 volt peak to peak. You can see the output in DC form. So that is, you can see for a negative half cycle you are getting the output as 3 volt, whereas for positive half cycle you are getting it as 1.5. Clearly observe the output. For negative you are getting it as 3 volt, for positive you are getting it as 1.5. Now see the transfer characteristics, put it to ground. So sorry, first keep it to the middle, then put it to bring this down, this knob, keep it in the center, input AC, output AC. So you can see the transfer characteristics. This is around, this is exactly 3 volt, this is 3 volt, this is 1.5 into 2, 1.5 into 2. So this is 3 volt, this is 1.5. So in case of this, whereas there will be certain questions given in terms of giving some other waveform, so that time you should be careful of designing the output in terms of R3, R4 or other values of your resistors. So this is how for each of the inputs your output will vary in case of a full wave precision rectifier. Thank you.